Okay, so this is a video where I just want to walk through this example right here. This was from slide 18 in today's lesson. Find the height of the isosceles trapezoid. So first thing I want to do is I want to mark up the isosceles trapezoid a little bit just so it looks like it actually is an isosceles trapezoid. So remember, for trapezoids, we have two bases, and those two bases are parallel. So I'm going to add our parallel symbols through the top and the bottom. We know those are the parallel sides because I think they very clearly are going the same direction. They're both going horizontally. And so that'll be base 1 and base 2. And then for it to be isosceles, remember, our two legs need to be congruent. And so that would be our left side and our right side in this diagram. So let's add slashes through those. And that shows that they are congruent. And so what we want to do here is find the height of our trapezoid. And to be able to find the height of our trapezoid, of course, we need to know what the height is. Now, back in trimester 1, we did a lot of work with finding areas of things. And actually, we did a lot of work with finding areas of trapezoids. And the area of trapezoids and just areas in general, we talked a lot about how area is normally based around a figure's base and its height. And your base and your height always make a 90-degree angle with each other. And so our height in this example is one of these things right here, where we connect like the top base and we draw this dashed line down all the way to the bottom base. That's what our height is. So in a trapezoid specifically, your height connects your top base and your bottom base. And so I'm going to put an H there, and that means height, right? Now, one thing about base and height is they always make a 90-degree angle with each other. And so I'm going to put a 90-degree angle symbol down there on the bottom. Now, the reason why we are doing this and the reason why that's kind of important is because take a look what starts to form over on this left side once we draw that height in there. We're starting to form a triangle. And not only a triangle, but a right triangle. We have that 90-degree symbol in there, so this is a right triangle. And almost every single time over the last couple weeks that we've had a right triangle, we've ultimately tried to solve for a missing side of the right triangle using our Pythagorean theorem. So a squared plus b squared equals c squared. Now, in order for a squared plus b squared equals c squared to work, you need to know two sides, right? If you know two sides and you're just missing one, then you label everything a, b, and c, and you algebraically, plug it in and solve for the missing side. The only problem right now is we only know two sides. We know the 13, we don't know two sides. We only know one side. We know one side's 13. We do not know h, and obviously that's going to be the last step because that answers our question. But we also don't know this bottom side from our orange triangle. We don't know that. And if we're going to use this orange triangle and use a squared plus b squared equals c squared to solve for h, we need to know the bottom length of this of the orange part of this orange triangle, right? And then we'll know the 13, we'll know that one, and we can use that to solve for h. And so how can we figure that out is really the question here. Well, I drew my height on the left side, and it started at the top corner of the base up top. What I want to do is I want to draw another height, but I'm going to draw it from the top right corner this time. So I'm drawing another height coming down on the right side. Now, it's not that important. We need to draw it, but we're not going to work on the right side. We're still going to work on the left side. But what we want to notice here is this. Those two heights are drawn exactly the same distance away as the distance of our top base, right? They were drawn from the top two corners of our base 1. And so the distance away from each other that our two heights are, it's always 20. It's 20 at the top, it's 20 in the middle, and it's also 20 down on the bottom. And that's really important because we know that the bottom side is 44 in total, but we don't want to know the total. We want to use that to figure out how long, this little orange part of our right triangle on the left is. And so what we're trying to do is we're trying to chunk up this bottom. We're trying to see how does this 44 split itself up. Well, we know that in the middle, from one height to the other height, is 20 because that's how long the top is. And so that gives us some information. That's 20 out of our total 44. And so that means what's left over for that side and that side is 44 minus 20, right? Which is 24. So the orange sliver on the left side and then the other equivalent piece on the right side, they have to be 24 in total because the middle is 20 and the whole thing is 44. So 20 plus 24 is 44. Now, one thing that occurs inside of an isosceles trapezoid is once you figure out how much the middle chunk is, the two remaining chunks on the end actually end up being equal. And so we know that in total, those two end remaining chunks have to be 24, but they also have to be equal. So if we do 24 divided by 2, that's telling us that each little piece has to be 12. So 12 is the bottom of our orange triangle on the left, and it's also the bottom of the triangle on the right. All right, but we're not going to worry about the triangle on the right. Now that we have the bottom of the orange triangle on the left, now we have our information. But just real quick to remind you, right, we split up this whole bottom. We know the left side's 12, we know the middle's 20, and the right side's 12. 12 plus 20 plus 12 gives us 44, as the total should be. But then what's most important now is we can zoom back in over here to this orange triangle. We now have two known sides. We know one is 12, we know one is 13, and then we just know the other one is h, but because we know the other two, we can now solve for h, again, using the Pythagorean theorem. A squared plus b squared equals c squared. So let's do that. Let's work on this orange triangle. Let's label the sides as a, b, and c, and then let's solve for h, right? And so let's find our 90-degree angle. Here it is. Across from the 90 is always going to be pointing at side C. That's our hypotenuse. So 13 is C. That means 12 and H are A and B. So I'll just call 12A and H B. And so let's plug that in. A squared, well, we want to replace A with 12. So that'll be 12 squared plus. And then B is H. And so we'll put it H squared. And then that equals C squared. And C is 13. So 13 squared. And so let's start by squaring everything. Remember, squaring is like multiplying by itself. So 12 times 12 is 144. H squared just stays as H squared for now. And then 13 times 13 is 169. Now, we want to get H squared by itself. Right now, it's being added with 144. And so let's subtract 144 from both sides to get H squared by itself. So that'll tell us that H squared equals, and it equals 169 minus 144, which is 25. And so then the very last step here would be we need to square root both sides. By doing that, that brings H squared down to H, which is what we want. And then we just type square root of 25 into our calculator, and the square root of 25 is 5. And that's our answer. Our height is 5. And so really what our goal was here is to recognize that when we draw a height, it kind of creates, a right triangle on one of the sides of our trapezoid. And so then what we'll try to do is split up whatever bottom side we've got to try to get two sides in our triangle. And then we do the Pythagorean theorem and solve for h. And again, in this problem, h turned out to be 5. So I hope that was helpful for you. Thank you for your question, and have a great rest of your day.